Number 27. The following nuclei do not lie in the band of stability. How would they be expected to decay? And then we have lithium that has a mass number of 9 and an atomic number of 3. Now they do say that this does not lie in the band of stability, which means that this would be an unstable nuclide, or even better, it would be classified as radioactive. So that means that it's going to decay somehow to turn into a more stable nuclide, whoever that would be. But now there's, a majority of 4 different types of decay modes. There's beta emission, positron emission, electron capture, or alpha emission. Which one is this one going to go? Well, first things first, always look at that atomic number. If you're dealing with huge nuclides with an atomic number greater than 83, it's got to lose a lot of mass fast, so alpha emission would be the way to go. But this lithium only has an atomic number of 3, so we can rule out the alpha emission. But now, talks about NP ratios, whether they're high or whether they're low. But if you want to find out an NP ratio, you would have to find the total number of neutrons, that's what the N stands for. You would have to find the total number of protons, and a ratio is just a fraction. So you would have to take your neutrons and divide by the protons to see whether you have a relatively high value or a relatively low value. But I think that there's an easier way, which I will show you here. If you have an N to P ratio that's generally high, high goes with high mass numbers. So if you have a N to P ratio that's high, that's going to correlate with a higher than normal mass number. And then on the flip side, if we're talking about an N to P ratio that's low, this is going to be dealing with a low mass number than normal. So a lower mass number. Now, the mass number or the atomic mass, you could say whichever one you want, but the mass number that they gave us was 9 here. But now the question is, how am I going to know whether that 9 is a high value or a low value? Well, good question. Enter in the best supplemental piece of information from the chemistry course, the periodic table. So get your periodic tables out, and we're going to look at lithium, which is the Li. Now on my periodic table, it might be a little bit different from yours, but you're going to look at the average atomic mass. So in my periodic table, it says that it's roughly about 6.94, which means that they crunched all of the isotopes generally found on Earth with its percentages, right, their natural abundances, and it came up with an average amount of 6.94. Now round this to the nearest whole number. 6.94 is very, very close to 7. 7 isotope of lithium would be 1, the most abundant, and B, it would be the most stable. Generally speaking, on this Earth, we want to produce stuff that's really, really, really stable. So a lithium-7 is the stable version. The one that they gave us was a mass number of 9. And now we have that context because 9 is obviously greater than 7, so they gave us a high mass value or a mass number. And if we have high mass numbers, that's an N to P ratio that's high, and there's only one type of emission. It's going to be releasing a beta particle into the atmosphere, which is an electron. So all you're doing is you're just emitting an electron into the atmosphere, and that's the type of decay mode. And that's the end for this. What do you think? I hope this helped. Let me know in the comments. I love talking to you guys in my spare time. Good luck on your tests and quizzes. At the moment of making this video, it's a brand new school semester, so good luck to you. I know that generally nuclear chemistry is taught at the end of the semester, so if you are watching this at the end, and while I'm recording this at the beginning, it's kind of like, two worlds collide, but if you're watching this at the end, good luck on your finals. You got this. And if you want to become a member to the channel, we just opened up memberships for the new school semester. So you could check that out. There's 4 different tiers. You might find one that suits your fancy. But yeah, thank you so much for all your support, and I look forward to helping you soon. Bye-bye.